There are distances in the universe so vast they can't be measured in miles or years, only in silence. Between one heartbeat and the next, light travels 7 times around the Earth. Yet even light, the fastest thing in existence, takes 5 hours to reach Pluto and more than 4 years to touch Proxima b. We built rockets, sails, and dreams to chase them, but the deeper we look, the more we find the real barrier isn't out there. It's the limits of what a human lifetime can endure. So why can't we go? What stops us from reaching those distant worlds we can already see? Like and subscribe if you enjoy these cosmic journeys. It truly helps this channel grow. Now, close your eyes, slow your breath, and join us on a journey across the impossible. Let's begin. Space is not just empty, it's expansion itself. Every kilometer between worlds stretches time, bends energy, and tests the limits of everything we know. From Pluto's frozen plains to Proxima b's distant orbit, distance stops being a number. It becomes an abyss that swallows our best intentions. To the human mind, distance feels measurable, a car ride, a flight, a voyage across an ocean. But space rewrites what distance means. Between Earth and the Sun, 8 minutes. Yet to cross the gap between the Sun and Pluto, light must travel for more than 5 hours. By the time a radio signal leaves our antennas and reaches the edge of the solar system, the world it came from has already changed. Governments shift, cities rise and fall, and still, that faint pulse of human intent moves through the dark. Our spacecraft, tiny mechanical pilgrims, drift through that silence carrying whispers of home, golden records, data streams, fragments of music, memories of oceans and rain. Voyager 1, the farthest thing we've ever made, has been traveling for nearly 50 years and has only just stepped beyond the sun's influence. It still sends us signals weaker than the light of a candle seen from Jupiter. And beyond it, the distances stretch until the word far loses meaning entirely. If you could watch space unfold, you'd see the geometry of impossibility. Each step farther from Earth demands exponentially more energy. The gap between planets grows not just in size, but in difficulty. To go from Earth to Mars is one challenge. To reach Neptune is another world entirely. Beyond that, to cross from our star to the next is to face a chasm so deep that even imagination begins to falter. Between Pluto and Proxima b lies the void between stars, a gulf filled not with nothingness, but with dust, radiation, and the faint magnetic hum of ancient explosions. It is the true ocean of the cosmos, and humanity stands only on its shore. Even light, tireless, and pure, takes over 4 years to bridge that divide. To us, bound by time and fragile bodies, it might as well be forever. And yet, we look across it. We send telescopes to peer through the darkness, to find worlds orbiting distant suns. We name them, study them, dream of walking their alien shores. We build stories out of photons, crafting meaning from the faintest glimmers. The distance that divides us becomes the canvas of our curiosity. In that vastness, we discover something profound, that the true barrier isn't space at all, but time. The time it takes to travel, to communicate, to change. The universe reminds us that movement and patience are the same act, viewed through different scales. We are slow creatures in a fast cosmos, but perhaps that's what makes us human. We reach anyway, because somewhere beyond that immeasurable gulf, beyond Pluto's pale shadow and Proxima's crimson light, the universe waits, not for us to conquer it, but to understand it. And that understanding begins not with arrival, but with awe. Humanity's fastest spacecraft, Voyager 1, travels at 17 kilometers per second. Yet even at that speed, it would take more than 70,000 years to reach Proxima b. Our rockets burn bright but short, like matchsticks in the wind of eternity. 70,000 years. That is nearly the entire span of human civilization. Every empire, every language, every song that's ever been sung. In that time, continents shift, stars drift across the sky, and even the memory of who we were would fade into dust. Voyager, that tiny metal ambassador, would still be flying, patient and alone, with its golden record whispering into a silence too vast to echo back. The truth is that we've barely begun to move. Our rockets scrape the edges of possibility, clawing against gravity just long enough to slip free of Earth's grasp before sputtering into the black. Each launch is a brief defiance, a declaration that we will not stay bound to one world forever. Yet even our greatest triumphs barely nudge us forward on the cosmic scale. The speed that carried Apollo to the moon would take more than 900 centuries to reach the nearest star. The problem is scale. Space doesn't just measure distance, it measures despair. Each additional kilometer per second requires exponentially more fuel, more energy, more will. To double our speed isn't twice as hard, it's 10 times harder. Rockets gulp propellant like lifeblood, burning oceans of fuel just to accelerate a little faster. And even if we had limitless energy, there's another truth that physics refuses to bend. The faster you go, the heavier you become. Einstein's equations whisper a quiet warning: approach the speed of light, and the mass of your ship approaches infinity. To move faster, you would need infinite energy. And so we linger near the threshold, explorers at the edge of a map that stretches forever outward. We dream of fusion drives, engines that would harness the power of the stars themselves, or sails made of light, pushed by the same radiation that warms our faces each morning. But these are still dreams, blueprints of a future not yet born. The distance between theory and launchpad remains wider than any orbit we've conquered. Still, we build, we test, we fail, and we try again, because every machine we send into the dark teaches us something new about how to reach further. Each success, each fragment of data from the edge of our solar system becomes a promise that one day we might find a way past that invisible line. The edge of our reach is not a fixed place. It expands each time we dare to move. Once, it was the ocean's horizon. Then, it was the sky. Then, the moon. Then, the distant shimmer of Pluto. Every generation redraws the boundary, carving a little more meaning into the vastness. Perhaps one day, we'll look back and realize that impossible was just another word for not yet. But for now, our rockets burn, our signals fade, and our tiny ships drift toward eternity. Proof that even on the edge of our reach, humanity still reaches. We once thought of Pluto as the edge of our solar system, a final destination. But when New Horizons flew past it in 2015, it didn't find an ending. It found a beginning. Mountains of ice, valleys of nitrogen, and shadows cast by a distant, dying sun. For decades, Pluto was little more than a pixel, an icy enigma orbiting in the dark. Discovered in 1930, it was a ghostly speck on a photographic plate, moving just enough for astronomers to realize it wasn't a star. Generations imagined it as a frozen wasteland, a lonely relic at the edge of everything. But when New Horizons arrived after nearly a decade of travel, the mystery deepened instead of ending. What it found defied every expectation. Pluto wasn't inert, it was alive in its own frozen way. Towering ice mountains rose higher than the Rockies, sculpted not from stone but from solid water as hard as granite. Glaciers of nitrogen crawled slowly across vast plains, their flow measured not in hours or years, but in millennia. The surface shimmered with color, hints of pinks and oranges caused by complex organic molecules called tholins, formed when sunlight strikes methane. Even in the most distant dark, chemistry persists. New Horizons revealed a world both alien and heartbreakingly familiar. There were valleys, cliffs, and plains that spoke of geological processes still at work. A massive heart-shaped region, Tombao Regio, gleamed like frost against the endless black, a symbol of warmth in a place that should have none. Scientists realized that under Pluto's icy crust, there might be something extraordinary, a subsurface ocean, liquid and ancient, hidden beneath kilometers of frozen shell. In the silence of the Kuiper Belt, life's ingredients may still wait, preserved in cold eternity. But Pluto is more than just an object of science. It's a mirror for human curiosity. For generations, it represented our yearning to know where the sun's influence ends and the star's domain begins. Even its reclassification from planet to dwarf planet sparked something deeply emotional. We felt its demotion not as a scientific correction, but as a kind of loss, proof that the cosmos doesn't bend to our definitions. Pluto reminds us that edges are illusions. What we call the end often becomes the start of a new map. Beyond it lies the Kuiper Belt, a vast collection of icy worlds, remnants of the solar system's birth. Comets, asteroids, and hidden moons drift in that frozen halo, carrying the raw materials that once built planets, and perhaps, one day, life itself. As New Horizons continued its journey into that deep twilight, it left Pluto glowing softly behind, a distant ember in the sun's fading light. The spacecraft's instruments grew quiet, its mission nearly complete, but in its silence, it carried a message. There are no true frontiers, only horizons we have yet to cross. Pluto was never the edge, it was the doorway. A reminder that even in the coldest, loneliest places, on Pluto, sunlight is a whisper. Noon there feels like Earth's deep dusk, the sun a pale coin in a black sky. The air is so thin you couldn't take a single breath. It is a place where silence has mass. Standing on Pluto, if you could stand at all, would feel like existing in a dream between night and extinction. Shadows are endless and soft-edged, stretching across ice plains that gleam faintly with blue frost. The light that reaches the surface has traveled billions of kilometers, filtered and weakened until it becomes something else entirely. Not illumination, but memory. The horizon curves sharply beneath you, its edges tinted with a faint halo of scattered light. In this distant place, the sun itself is just another star, familiar, yet impossibly far. Every breath of Pluto's atmosphere is fleeting. It's composed mostly of nitrogen, with traces of methane and carbon monoxide. But it isn't stable. When the planet moves farther from the sun, along its elongated orbit, that fragile atmosphere collapses, freezing and falling to the ground as snow. Seasons here are epochs. A single Pluto year lasts 248 Earth years. Entire human civilizations could rise and fall before its next summer dawns. If you walked across its plains, your footsteps would make no sound. There is no air dense enough to carry noise, no wind to echo your presence. The landscape itself feels timeless. Mountains of solid water, glaciers that crawl at the speed of continents, cliffs that glow faintly beneath starlight, reflected off Charon. Its massive moon. Together, Pluto and Charon are locked in an eternal dance, each showing the other the same face forever. Their gravitational bond means no sunrise, no sunset, only a sky that tilts slowly with the patience of eternity. At night, the stars blaze with unnatural clarity. With no real atmosphere to blur their light, the cosmos appears raw and infinite, a tapestry of white fire against black crystal. Even from so far away, Earth would still be visible, a faint, blue pinprick near the sun. The idea that anyone could live there, breathe there, dream there, it would feel miraculous. And yet, Pluto is not dead. Beneath its frozen crust, scientists believe there may be a vast ocean of liquid water mixed with ammonia, trapped and insulated by layers of ice. That hidden ocean, dark and ancient, may have endured for billions of years. If it exists, it would be one of the most distant places in the solar system where life could still, just possibly, be alive. Pluto lives at the threshold between sunlight and infinity. It's the last flicker of warmth before the long cold of interstellar space. To stand there would be to experience time differently, to feel both the fragility of light and the endurance of stone. It's not merely a world of night, it's the pause between days, the twilight of our solar system, a quiet so deep it feels like the universe holding its breath. Every second, light travels 300,000 kilometers, yet even light takes 5.5 hours to reach Pluto and over 4 years to touch Proxima b. To travel there is to move against light itself, to rebel against physics. Distance, in the cosmic sense, isn't just a measurement, it's a law. It defines what can exist, what can communicate, what can endure. Between every planet, every star, there is a silence so vast that even light, the universe's swiftest messenger, struggles to keep pace. The tyranny of distance is absolute. It humbles even the brightest minds and the most ambitious machines. For every meter we travel into space, the void demands payment in time, energy, and patience. Imagine a beam of sunlight leaving the surface of the sun. In 8 minutes, it reaches Earth. A few minutes more, and it graces the outer planets. Jupiter in 43 minutes, Saturn in over an hour. But that same ray must travel more than 5 long hours to reach the faint horizon of Pluto. By the time it does, it's no longer warmth, it's a whisper of what once was, spread thin across billions of kilometers. Now stretch your mind farther. To reach Proxima Centauri, the nearest star beyond our Sun, that same beam of light must travel for more than 4 years, crossing space so empty it contains, on average, just 1 atom per cubic centimeter. Between those rare particles, nothing exists. No sound, no friction, no boundary. It is the ultimate isolation. For humanity, such scales are almost incomprehensible. Our fastest spacecraft would take tens of millennia to reach that tiny red star, and even then, it would arrive long after our civilizations had turned to legend. To move between stars is to move beyond the limits of life itself. The tyranny of distance is not simply about how far, but how long. And yet, distance does more than divide. It defines meaning. It gives weight to light, to discovery, to longing. We look at Pluto's pale reflection or at Proxima b's dim orbit and feel the pull of something deeper than curiosity. Distance makes us dream. It forces us to ask whether the universe's boundaries are physical or psychological. Each signal we send to our probes, each pulse of radio waves, becomes a letter to the future. Are you still there? We ask. Hours later, or years later, the answer comes back. A faint yes, trembling through the dark. That delay, that gulf of silence between question and reply, is the voice of distance itself. But perhaps distance isn't the enemy. Perhaps it is the teacher. It reminds us that patience and wonder are the same thing. That to explore the universe, we must first learn to measure time not in seconds or years, but in generations. Light may travel faster than anything, but even it cannot escape the truth that the cosmos is vast beyond comprehension. And still, we send our signals, build our ships, and reach for the stars. Because to rebel against distance is to be human. To look at the infinite and whisper, "We're coming." Speed is energy, and energy is cost. To send a ship fast enough to reach Proxima b in a human lifetime, we'd need more fuel than exists on Earth, an entire planet burned just to touch another star. At first, speed feels like freedom. The faster we go, the closer we seem to get to the impossible. But in the vacuum of space, every fraction of acceleration demands a sacrifice. For each meter per second we gain, the universe asks for exponentially more energy in return. The equations are simple, elegant, and merciless. You can escape gravity, you can escape atmosphere, but you can't escape math. The rockets that lifted us to the moon burned thousands of tons of fuel to move a handful of humans just 400,000 kilometers away. To reach Pluto, New Horizons needed to accelerate to over 58,000 kilometers per hour, one of the fastest speeds ever achieved by a human-made object. Yet even at that incredible velocity, it took more than 9 years to cross the gulf of our own solar system. To reach Proxima b, New Horizons would have to travel 10,000 times faster, and even then, the trip would still take decades. If we tried to power such a journey with chemical fuel, the kind that sends rockets into orbit, the numbers break apart into absurdity. You'd need oceans of liquid hydrogen, continents of oxygen, and a launch platform the size of a small moon. Every extra drop of fuel adds mass, and that mass itself demands even more fuel to move. It's a loop without mercy. You burn more, you weigh more, you burn more again. Scientists call it the rocket equation, but it might as well be a cosmic law of diminishing returns. For every problem we solve, the cost of speed grows higher. Nuclear propulsion could help. Fusion or antimatter engines could, in theory, accelerate a ship to a significant fraction of light speed, but those are technologies that exist mostly on paper. Even if we could build them, controlling such energy would be like holding a star inside a tin can. And there's another hidden cost: momentum. The faster you go, the harder it becomes to stop. A ship traveling near the speed of light wouldn't just need colossal power to get there. It would need nearly the same amount to slow down once it arrived. Without a way to brake, our interstellar explorers would fly past their destination in seconds, doomed to wander the void forever. Speed, then, isn't just about how fast we can go. It's about how much we're willing to pay, in fuel, in time, in risk. Every acceleration is a bet against entropy. Every voyage is a question. How much is discovery worth? Perhaps, one day, we'll find new ways to cheat this balance, light sails pushed by lasers, or engines that feed on the particles between stars. But until then, we remain bound by the same paradox. The faster we wish to move, the heavier our dreams become. The universe will always let us chase it, but never for free. Chemical rockets got us to the moon. Ion drives carried probes to the outer planets. But to cross interstellar space, we'd need engines that don't yet exist: fusion drives, antimatter propulsion, or sails pushed by starlight itself. Every form of propulsion humanity has built so far has been a beautiful compromise between ambition and physics. Rockets roar with brilliance and power, yet their lifespans are brief. Most of their fuel is spent simply escaping Earth's gravity. Ion drives, in contrast, are gentle and steady. They accelerate slowly, like a sigh drawn over months or years, trading brute force for efficiency. They can push a spacecraft across billions of kilometers with astonishing precision. But even their patient endurance fades before the scale of interstellar space. Beyond our solar system, momentum isn't enough. The gap between stars isn't measured in millions of kilometers, but in trillions. The propulsion methods that serve us here, rockets, thrusters, engines of flame and chemistry, are like paper boats set adrift on a cosmic ocean. They were never meant for distances that long or timescales that ancient. To reach another star, we need to build engines that don't just move through space, but redefine what motion means. That's where imagination meets physics. A fusion drive, for instance, would harness the same reactions that power the sun, fusing hydrogen atoms into helium, releasing immense energy in the process. A ship using such a system could, in theory, reach a tenth the speed of light. At that speed, Proxima Centauri would be only 40 years away. But the challenge lies not in theory. It lies in control. We have yet to achieve sustained fusion on Earth, let alone in the fragile confines of a spaceship hurtling through the void. Then there's antimatter propulsion, the holy grail of efficiency. When matter and antimatter meet, they annihilate completely, releasing energy with unmatched power. Just a few grams could equal the explosive energy of a nuclear bomb. But antimatter is unimaginably rare. Creating and storing it would require magnetic containment systems stronger and safer than anything we've ever engineered. One slip, one error, and the ship would become its own starburst. And then there are the light sails, delicate, glimmering sheets that catch photons instead of wind. They don't carry fuel at all. Instead, they are pushed by the pressure of light itself. Laser-driven sails could, in theory, reach incredible speeds, perhaps a fifth of light's velocity if powered by vast arrays of lasers on Earth. The concept is simple. the execution would be civilization-defining. These propulsion ideas stretch not only our technology, but our patience. They require cooperation across generations, funding that spans centuries, and a vision that sees beyond a single lifetime. But that's what space has always demanded, a kind of faith in the unseen, a promise to the future. Each new engine we imagine is another candle lit in the dark. Each test, each prototype, each failure brings us one breath closer to interstellar dawn. For now, we drift at the edge of possibility, our rockets dim embers against the stars. But somewhere in the blueprints and equations, the next fire is waiting to ignite. The one that will finally break the limits of propulsion and carry us across the cosmic sea. Leaving Earth isn't easy. Our planet's gravity demands almost all our fuel before we even reach orbit. Escaping the sun's gravity takes even more. Reaching another star means climbing an invisible mountain that never ends. Gravity is both our cradle and our cage. It shaped the Earth, holds our oceans in place, and keeps our atmosphere wrapped around us like a fragile veil. Without it, life could never have formed. Yet for those who dream of the stars, gravity is the first and greatest obstacle. To rise from the surface of our world is to defy a force that never stops pulling us home. Every rocket we launch begins with the same battle. The engines ignite, fire blooms, and the ground trembles as tons of fuel erupt into light. But most of that energy, around 90%, is spent simply fighting to escape Earth's grasp. By the time a spacecraft reaches orbit, it's already shed stages, tanks, and engines. What remains is a sliver of its former self, coasting delicately on the edge of freedom. This is why rockets must be so enormous and yet carry so little payload. For every kilogram of equipment we send into space, dozens of kilograms of propellant are consumed. To escape Earth's gravity well, a ship must reach 11.2 kilometers per second, over 40,000 kilometers per hour. That's the escape velocity, the speed at which our planet finally lets go. But that's only the beginning. Even once we leave Earth behind, we're still deep within the sun's gravitational domain. Every object in the solar system, planet, comet, or probe, is caught in the slow, endless pull of our star. To reach the outer worlds, we must fight the sun's grip just as we fought Earth's, trading speed and fuel for altitude in a game that never ends. Space agencies have learned to turn gravity itself into an ally. Instead of burning endless fuel, we use what's called a gravity assist. A spacecraft slingshots around planets, stealing a tiny bit of their orbital energy to gain speed. Voyager 2, for instance, used this cosmic billiard trick to visit Jupiter, Saturn, Uranus, and Neptune in a single flight. Each encounter hurled it faster and farther, like a stone skipping across a pond of planets. But even gravity assists have limits. There are only so many worlds in the solar system, and none of them can fling us hard enough to break free of the sun's reach entirely, not at the speeds required for interstellar flight. To escape not just a planet, but an entire star, we would need propulsion on a scale we have never built. The energy needed to break that final chain is beyond anything humanity has yet harnessed. In a way, gravity defines our story. It binds us to our origins, yet challenges us to leave. Every leap upward, every orbit, every mission, every dream is an act of rebellion against it. And maybe that's why the stars call to us so powerfully. Because somewhere deep down, we recognize that escaping gravity isn't just about physics. It's about evolution. It's about a species learning, one launch at a time, how to rise. Even if we could build the perfect ship, there's another obstacle: time. The human body, mind, and civilization itself aren't designed to last thousands of years. Space is not just far, it's forever. Distance can be measured, energy can be calculated, but time is the most unforgiving element in the universe. It is what erodes stars, planets, and memory alike, and it is the reason the dream of reaching another star feels so achingly out of reach. For us, a journey to Proxima b wouldn't just be long, it would be generational. A single voyage that might last longer than the existence of the nation, language, or culture that launched it. The universe operates on a rhythm beyond our biology. Human life is brief, measured in decades. Even our longest histories barely touch 10,000 years. But the distances between stars demand patience measured in millennia. A ship traveling at the speed of Voyager, one would take 70 millennia to arrive at Proxima Centauri. 70,000 years, enough time for entire species to evolve or vanish. By the time the ship reached its destination, everything that defined its creators might have turned to dust. This is the great paradox of exploration. The faster we move, the slower time feels. Einstein revealed that at near light speeds, time itself bends. For the traveler, seconds stretch. For those left behind, centuries pass. A crew racing toward another star might experience the trip as a single lifetime, while Earth would age beyond recognition. Loved ones would vanish into history. Civilizations would crumble and rebuild. To travel far enough, fast enough, is to leave not just home, but time itself. Then there is the question of endurance. No organism, no machine we've built, has yet proven capable of surviving the deep time of interstellar travel. Radiation, micrometeorites, cosmic dust, all eat away at metal and memory. Electronics degrade, signals fade, systems fail. Even the most advanced spacecraft we've ever launched will one day go silent, drifting endlessly through a darkness that no longer remembers their names. Some have imagined solutions. Generation ships, massive vessels carrying whole populations that live, age, and die on the way to another star. Their descendants would be born knowing nothing of Earth except through records and myths. To them, the ship would be the entire universe, its metal walls the horizon of existence. Others dream of cryogenic sleep, of suspending life until the destination is reached. But freezing the body is one thing. Preserving the mind, the spirit, the fragile web of consciousness that remains far beyond our reach. And even if we could cross that gulf, time would still mock us. For what would we find on arrival? A planet that has aged millions of years since we first saw its light. A world changed, or gone, or waiting in silence. Every image we have of the stars is a glimpse into the past. Every step we take toward them is a move into an unknown future. The time dilemma is not merely a scientific problem, it's an existential one. It reminds us that the universe doesn't move to our rhythm. To reach the stars, we must learn not only to travel through space, but to endure time itself. Until then, we remain here, tiny, brief, and luminous, watching the light of ancient worlds fade softly into the future. Pluto's surface lies below -230 degrees Celsius, where nitrogen freezes like rock and methane turns to frosty. Beneath that ice, scientists suspect a buried ocean, a hidden sea that has never known light. To stand on Pluto would be to stand in stillness itself. The air is so thin, it might as well not exist. Your breath would vanish into crystal. The ground beneath your boots would be solid water, hard as granite, glinting faintly beneath the dim light of a distant sun. The horizon would seem close, curved, and fragile, an edge of white and grey where the world ends and the cosmos begins. Pluto's cold is not just a lack of heat, it's a presence. At those temperatures, molecules barely move. Time seems to slow with the cold. The methane and nitrogen that form its plains are frozen in quiet motion, glaciers creeping across its heart-shaped region. Tombo Regio, like icebergs drifting in frozen air. Beneath this frozen shell, though, lies a mystery that refuses to freeze. Scientists believe that deep beneath Pluto's crust, perhaps hundreds of kilometers down, there may be a vast ocean of liquid water, mixed with ammonia, an antifreeze for alien worlds. If true, this hidden ocean has survived for billions of years, insulated by layers of rock and ice, warmed faintly by radioactive decay from Pluto's core. It would be an ocean untouched by sunlight, sealed since the beginning of the solar system, a time capsule of primordial chemistry. If such a sea exists, What could dwell within it? Not fish or kelp, or the shimmering creatures of Earth's waters, but perhaps simpler life, microbes, or even molecular patterns that mimic life's beginnings. After all, on Earth, life has been found in the darkest, most hostile places, beneath glaciers, around volcanic vents, inside rock itself. If the ingredients of life are everywhere, then maybe Pluto's secret heart is not barren, but waiting. Above this hidden world, the surface tells a different story. It is carved by impact craters and smoothed by nitrogen flows. There are mountains taller than Everest made of water ice, their slopes glowing faintly under starlight. Pluto's surface shifts over ages, sculpted by sublimation and freezing, where gas becomes solid and solid becomes gas in endless rhythm. It's a place where the seasons move slower than civilizations, where winter can last a century, and sunrise returns only once every earthly lifetime. Yet, despite the cold, there is beauty here, a delicate balance between chaos and calm. The sun may be a distant spark, but it still paints the surface with subtle shades of gold and blue. Shadows stretch endlessly. Charon, Pluto's moon, looms large in the sky, locked in eternal dance, both worlds circling each other in a quiet waltz that will never end. Beneath that frozen silence, a sea may still pulse in darkness. A world that was once dismissed as a lifeless rock now whispers of complexity and persistence. Pluto reminds us that warmth isn't always measured in degrees, that even the coldest hearts may carry the memory of fire. In the frozen heart of Pluto, the universe shows us a paradox, that even at the edge of the sun's light, there are worlds that still remember how to move, how to change, and perhaps how to live. Pluto's year lasts 248 Earth years. Seasons there are measured in generations. Winters can last for a century, and when they come, the atmosphere itself falls as snow. Imagine a world where the concept of a year outlives an empire, where a single season could stretch longer than the entire span of modern history. On Pluto, time itself seems to drift and linger, as though reluctant to move. The sun hangs low in the sky, casting dim twilight that never truly becomes day. When winter arrives, it does not creep in gently, it consumes. The faint gases that form Pluto's atmosphere begin to freeze, crystallizing into tiny flakes that drift slowly downward until even the air itself becomes part of the landscape. During these centuries-long winters, Pluto becomes quieter still. The thin atmosphere collapses onto the surface, blanketing the plains in frozen nitrogen and methane. Mountains disappear under the frost. Valleys fill with layers of glimmering snow that will not melt for generations. When the world finally drifts closer to the sun again, that ice sublimates back into gas, and the atmosphere returns, reborn from its own remains. It is a cycle of life and death written not in days, but in ages. Charon, Pluto's largest moon, watches this transformation in eternal silence. Locked in gravitational embrace, it never rises or sets in Pluto's sky, forever showing the same face. Together, they orbit a shared point in space, two frozen partners moving through a cosmic waltz so slow it can only be measured in patience. From Pluto's surface, Charon looms enormous, its grey plains faintly illuminated by reflected sunlight. Even in the deepest night, that faint glow gives the horizon a quiet, silvery outline. What would it be like to stand there during the heart of winter? You'd see no motion, hear no sound. The stars would burn brighter than diamonds, unblinking and eternal. The sun would be a cold spark, so distant it casts no warmth, only suggestion. Time would lose meaning. The ticking of a clock, the beating of a heart, these would feel irrelevant. The world would seem suspended between being and not being, waiting for the slow return of light. But Pluto is not dead during its long night. It's dreaming. Beneath the frozen crust, processes continue. Geological movements. Perhaps the faint stirring of a buried ocean. The slow drift of frozen gases shifting with subtle tides. The cold doesn't end life here. It preserves it, holding every molecule in place like a library of ancient possibilities. When spring finally returns, it comes not with flowers or rain, but with vapor and light. Frost becomes mist. The thin air shimmers with methane haze. Shadows retreat across nitrogen plains that have waited a human lifetime for dawn. The landscape remembers warmth the way memory remembers sound, faintly but faithfully. Pluto's long night reminds us that time is relative, that change can happen even when nothing seems to move. On this distant world, seasons are measured not in months or years, but in endurance, and perhaps that's the truest form of life in the cosmos. Not motion, not warmth, but the quiet, patient persistence to simply remain, waiting for the light to return. When New Horizons left Pluto behind, it became a ghost in the Kuiper Belt, its faint signal taking hours to reach home. It was the first and last visitor for centuries to come. In July of 2015, as humanity watched the first close-up images of Pluto arrive, there was a sense of triumph that rippled across the world. For the first time, we had seen the face of a world at the edge of sunlight, a place once considered unreachable, now revealed in sharp, shimmering detail. But for the spacecraft itself, the moment of glory was silent. As the images made their way back to Earth, traveling at the speed of light, New Horizons had already moved on, alone, coasting into darkness, its mission just beginning. After the flyby, the little probe continued outward into the vast, uncharted region beyond Neptune, the Kuiper Belt. It's a place filled with icy remnants, the building blocks of planets that never came to be. Here, time feels older. The sun is nothing more than a bright star, barely capable of casting shadows. Space becomes less like an ocean and more like a frozen museum, each fragment of rock and ice, a relic from the dawn of the solar system. Every day, New Horizons drifts another 1,000,000 kilometers from home. Its signal weakens with distance, now so faint that the giant dishes of NASA's Deep Space Network must listen intently, filtering cosmic noise to catch its whispers. A single transmission can take over 5 hours to reach Earth. The spacecraft speaks in pulses of data, slow, patient sentences written in binary, telling stories of dust, temperature, and light from places no human will ever stand. In that silence, it has become something more than a machine. It is a memory, an artifact of our species' courage to wonder. It carries, quite literally, a message for the cosmos, a small plaque bearing the signatures of those who built it, a dedication to exploration, and a piece of Earth's story cast into eternity. Like Voyager before it, New Horizons is a messenger from a civilization that dared to look beyond its cradle. In 2019, long after its encounter with Pluto, New Horizons flew past another ancient world, Arakoth, 2 icy lobes fused together like a cosmic hourglass, untouched for billions of years. The images it sent back revealed a surface as red as rust, shaped by time alone. It was a quiet triumph, another window into the past, another proof that even in silence, the pursuit of knowledge continues. Now, New Horizons continues its drift. Its plutonium power source grows weaker with each passing year. One day, the radio will fall silent, its instruments cold and still, but its journey won't end there. It will keep moving, forever, across a sea of stars, an eternal traveler bearing humanity's fingerprint. The lonely explorer will never return. But perhaps it doesn't need to. Its path reminds us that exploration isn't about coming back. It's about going further than anyone before. Out there, in the thin dark between suns, a tiny spacecraft sails onward, carrying a message as old as curiosity itself. We are here, and we are still reaching for the light. Past Pluto lies the scattered disk, a realm of icy bodies that drift at the edge of the sun's domain. Beyond that is the Oort cloud, a shell of comets extending halfway to the nearest star. Here, the sun is just another star among billions. This is the true borderland of our solar system, the twilight region where gravity begins to loosen its hold and the solar wind fades into the thin breath of interstellar space. It's a place without warmth, where sunlight is so weak that it no longer defines day or night. Out here, the sun's power dwindles to a memory, and the familiar becomes meaningless. Distance, temperature, even time itself dissolve into a slow, endless drift. The Kuiper Belt is the last place where we can still see the sun's influence clearly. It stretches like a frozen halo beyond Neptune, filled with remnants of creation, icy worlds, dwarf planets, and ancient debris left over from the birth of the solar system. These bodies, untouched for billions of years, are fossils of formation, the leftover clay from which the planets were sculpted. Pluto is one of them. But beyond Pluto, things grow stranger. The scattered disk extends farther still, its orbit stretched and twisted by the gravitational pull of Neptune, and perhaps even something more mysterious. Some of these distant objects travel so far from the Sun that a single orbit can take tens of thousands of years. They vanish into the dark and only rarely return, like comets visiting from deep time. It's here that astronomers suspect something unseen lurks. A hidden planet, massive and cold, perhaps 10 times the size of Earth. Planet 9, they call it, an invisible shepherd shaping the orbits of these icy wanderers. And beyond even that, beyond the Kuiper Belt and the scattered disk, lies the Oort cloud, a vast, spherical shell surrounding the solar system like a cosmic snow globe. It is a realm so distant that no spacecraft will reach it for millennia. The Oort cloud may contain trillions of icy objects, comets frozen in suspension since the dawn of the Sun. Occasionally, gravity stirs one from its slumber, sending it inward toward the planets in a long, glowing arc. A reminder that even the farthest edges of the solar system are not truly still. In the Oort cloud, the Sun is barely a star at all, just one among countless others in the galactic night. Its light is so faint that it would look no brighter than Venus does from Earth. The boundary between solar space and interstellar space is not a wall, but a fading gradient, a slow surrender to the vastness beyond. This is where home ends. Beyond the Oort cloud, the solar wind stops. The magnetic field of the Sun dissipates. Voyager 1, humanity's most distant emissary, passed into this interstellar medium in 2012. It now sails through space unclaimed by any star, drifting between suns, carrying whispers of our world into the void. To travel beyond the Kuiper Belt is to step outside the story of the Sun, to enter a place where time has no center and gravity no master. It is a realm of silence, older than memory, colder than thought. And yet, even here, our machines still move, our curiosity still burns. Because beyond the Kuiper Belt lies not emptiness, but the beginning of everything else. At the outer limits, sunlight fades until even solar power dies. A spacecraft here must sleep, running on batteries and silence. The universe beyond is darker than thought itself. There is a place where the light of the Sun becomes a memory. Beyond Neptune, beyond Pluto, the rays that once nourished Earth's oceans weaken to a thin trickle of photons. What was once bright and warm now arrives as a ghost, each particle of light travelling for hours, scattering faintly across frozen plains and dust. At such distances, the Sun no longer dominates. It becomes just another star in the sky, dim and distant, its warmth too fragile to sustain even the simplest machine. For spacecraft like Voyager and New Horizons, this is where endurance becomes everything. Their solar panels are useless here. The sunlight is too faint to feed them. Instead, they rely on the slow decay of radioactive material, tiny particles breaking apart inside their power cores, releasing enough energy to whisper across the stars. It's a form of patience written in physics, a technology designed not for speed, but for survival. Each watt of power is precious. Instruments must sleep, awakening only to take a measurement, send a signal, or stretch an antenna toward the dim speck of Earth. Communication becomes a waiting game. When Voyager 1 speaks to us now, its voice takes over 22 hours to arrive. The data rate is slower than a household modem, a a few bits per second, traveling through billions of kilometers of emptiness. The silence between question and reply can last almost 2 days. It is the loneliest conversation ever held. Out here, beyond the warmth of the sun, space grows truly black. There is no scattered light, no blue sky, no dawn or dusk, only the eternal glow of distant stars. Cosmic rays sweep past like invisible wind, and the interstellar medium, a thin mist of dust and atoms, surrounds the craft like a cold ocean. Each moment it drifts further, the pull of the sun weakens, until eventually, gravity itself begins to fade into the background hum of the galaxy. For the spacecraft, there is no turning back. The last sunlight it will ever feel is already behind it. Its panels, once warm, now coated in frost. Its cameras see only the faintest outlines of stars. In this infinite night, even heat itself becomes a form of light, radiating softly into nowhere, a quiet defiance against the cold. But this darkness is not empty. It is alive with history. The faint background radiation that fills the void is the afterglow of creation, the lingering whisper of the Big Bang, stretched thin across eternity. It hums in microwaves, in invisible frequencies that once filled the newborn universe with fire. Even as the sun's voice fades, another, older one, takes its place. The sun's last whisper, then, is not silence, it's surrender. A hand reaching into the void, trusting that something will still listen. It reminds us that even as light weakens, it never truly vanishes. It only travels farther, slower, gentler, until it becomes part of the cosmic background, the quiet breath of a universe that never stops speaking. And as our tiny explorers drift into that vast, unending sea, they carry that whisper forward, our final echo of warmth, fading gracefully into forever. Proxima Centauri, the closest star to our own, is 4.24 light-years away. In cosmic terms, it's next door. But in human terms, it's eternity. That number, 4.24 light-years, sounds almost manageable, like a small skip across a galactic neighborhood. But light-years are deceptive units, made of distance so immense that language itself begins to falter. 1 light-year is nearly 10 trillion kilometers. Multiply that by 4, and the gap between our Sun and Proxima Centauri stretches wider than imagination allows. It is the kind of distance where seconds turn meaningless, where journeys are measured not in time, but in civilizations. Even if you traveled at the speed of our fastest spacecraft, you wouldn't live to see even the first fraction of the journey completed. Voyager 1, humanity's furthest traveler, has been sailing through space since 1977, and in nearly 5 decades, it has only covered 0.002 light-years. At that rate, it would take 75,000 years to reach the nearest star. By then, the continents on Earth would have shifted, the night sky would have changed, and the memory of our species might exist only as dust. And yet, Proxima Centauri calls to us. It is part of a trinity, 3 stars bound in a slow, celestial dance known as the Alpha Centauri system. 2 bright suns orbit one another, and far beyond them, Proxima trails like a lonely ember. It's a red dwarf, smaller and cooler than our own sun, glowing not golden, but crimson. Its light would paint any nearby world in shades of dusk, eternal twilight under a fading red sky. Orbiting this faint star is Proxima b, a planet just a little larger than Earth. It lies in the habitable zone, the region where liquid water could exist. To astronomers, it is one of the most tantalizing discoveries in history, a potentially life-bearing world right next door, at least by cosmic standards. But the cruel irony remains. It is close enough to see, yet impossibly far to touch. When we look at Proxima Centauri through telescopes, we are seeing it as it was 4 years ago. Its current light hasn't reached us yet. Every star in the sky is a time capsule, showing us not how the universe is, but how it was. Even the nearest one is a message from the past, traveling tirelessly through the dark to reach our waiting eyes. It is easy to forget that the universe doesn't scale to our hopes. To cross even 1 light year at the speed of our technology would demand energy and patience beyond measure. It's like standing on the shore of an ocean and realizing that the nearest island lies across eternity itself. And still, we try. We aim telescopes, design star probes, and dream of sails made of light that might one day bridge the divide. Because while the nearest star isn't near, it's not unreachable forever, just unreachable for now. Proxima Centauri is a reminder that the universe isn't cruel, it's simply vast. It stretches the boundaries of what we can imagine, asking not whether we can reach, but whether we can keep reaching. The nearest star isn't near, but its faint red glow is proof that, even across light years of distance and time, something still connects us, a thread of curiosity, stretched across eternity, still pulling us forward into the dark. Proxima is a red dwarf, smaller, cooler, and dimmer than the sun. Its light would paint the sky crimson, bathing any world around it in perpetual dusk. If you stood on the surface of a planet orbiting Proxima Centauri, you would never see a golden sunrise. There would be no blue sky, no blazing noon, only a horizon drenched in red. The light would be dim, heavy, and constant, casting long shadows that never quite disappear. Even at its brightest, Proxima's radiance would resemble the last moments of an earthly sunset, when the world softens into colour and the stars begin to stir awake. Red dwarfs like Proxima are the quiet engines of the cosmos. They make up the vast majority of stars in our galaxy, small, enduring furnaces that burn their fuel so slowly they can live for trillions of years. Compared to our Sun, they are unassuming, faint, and easily overlooked. Yet they are the universe's survivors. Long after stars like ours have bloomed and died, the red dwarfs will still be glowing, their light washing across frozen worlds in the deep future. Proxima's light is not only dim, it's deceptive. To the human eye, it would feel calm, even gentle. But beneath that soft glow hides a volatile heart. Red dwarfs are prone to violent outbursts, flares that erupt with bursts of ultraviolet and X-ray radiation, powerful enough to strip the atmosphere from any planet too close. In a single moment, that dusky calm could turn lethal, the red sky igniting into a storm of invisible fire. Still, it's not hard to imagine the haunting beauty of such a world. The sky would be filled not with blue, but with deep rose and violet tones. Oceans, if they existed, would shimmer like liquid copper under the dim light. Shadows would stretch endlessly, their edges blurred in the eternal dusk. Nights would come softly, blending seamlessly into days, as if time itself were exhaling. For any life beneath Proxima's glow, survival would mean adaptation. Eyes, if they existed, might evolve to see in the infrared, to read heat instead of light, to navigate a world where the sun never truly rises. Plants, if they grew, would need to harness the meager warmth differently, perhaps absorbing every photon, glowing darkly under the crimson sky. Life here would not resemble life on Earth. It would whisper instead of shine. Astronomers often romanticize red dwarfs as the perfect stars for longevity, the eternal flames of the galaxy. Yet for all their endurance, they challenge our sense of comfort. Their worlds are strange, their light alien, their warmth uncertain. And still, we look toward them with fascination, wondering whether under those dim skies, something stirs, something that breathes, endures, and dreams under a red sun. Proxima's light reminds us that sunlight is not universal. Every world sees its parent star differently: gold, blue, red, or invisible. And perhaps that is what makes the cosmos so endlessly alive. Each beam of light is a signature, a fingerprint of a star, carrying its history and temperament across the dark. In Proxima's red glow, we glimpse a paradox: the light of eternal life and the fire of sudden death. It is both a promise and a warning, a reminder that beauty and danger often share the same light. Discovered in 2016, Proxima b orbits within its star's habitable zone. It might have oceans, an atmosphere, perhaps even life. but no telescope can yet tell us for sure. It is both near and unreachable. When astronomers first detected the faint wobble of Proxima Centauri, the subtle tug that revealed a hidden planet, hope surged across the scientific world. For the first time, we had found an Earth-sized world orbiting the closest star to our own. It wasn't some distant exoplanet thousands of light years away, but a world next door, cosmically speaking. And in that small motion of a dim red star, humanity glimpsed the most powerful illusion in the universe: possibility. Proxima b orbits its parent star every 11 Earth days, close enough that it receives nearly the same amount of energy from its dim sun as Earth does from ours. This makes it what scientists call a temperate world, neither scorched nor frozen, but balanced in a fragile band where liquid water could, in theory, exist. And where there is water, there may be life. Oceans may shimmer under the faint red light. Clouds may drift slowly in a thin, alien sky. But proximity brings peril. Proxima b's closeness to its star means it is likely tidally locked, one side in eternal day, the other in endless night. The bright side might blaze under a dim but constant sun, while the dark side freezes in shadow colder than any polar winter. Between them, in the narrow band of twilight, there might exist a ring of balance, a place where temperatures soften, winds circulate, and perhaps, under the glow of a red horizon, life could cling to survival. If an atmosphere exists, it could protect against the fierce radiation storms that Proxima Centauri unleashes without warning. Without that blanket of air, though, the planet's surface would be stripped bare, oceans evaporating, molecules torn apart by ultraviolet light. Whether Proxima b has held onto its atmosphere or lost it to stellar violence remains one of astronomy's most haunting mysteries. From Earth, Proxima b is too small and too distant to be seen directly. We know it only through shadows and movements, tiny shifts in starlight measured by precision so fine it borders on magic. Each fluctuation, each fraction of a second in brightness, tells us something about the unseen world it conceals. But imagination fills the rest. We paint it in colors we can't confirm, oceans we can't prove, and winds we can't feel. And yet, even this faint knowledge changes everything. They exist around the smallest stars, in the quiet corners of the galaxy, orbiting suns dimmer than campfires. It whispers that maybe, just maybe, we are not alone, that life could find a foothold in places we never thought to look. For now, it remains only a light curve, a distant heartbeat in data. But to those who dream of other skies, Proxima b is more than a planet, it's a promise. A reminder that the cosmos still holds secrets waiting just beyond reach, shimmering at the edge of possibility. It is both near and unreachable, yes, but so was every frontier once, until someone found the courage to look closer. Proxima b's star is volatile, releasing flares that could strip its atmosphere in seconds. A planet close enough for warmth is also close enough for destruction. To orbit a red dwarf like Proxima Centauri is to live on the edge of survival. The same closeness that makes life possible, providing enough energy for liquid water, also exposes a planet to the fury of a restless sun. Proxima may be small compared to our sun, but it is far from gentle. Its magnetic fields twist and snap with violent precision, releasing bursts of radiation that dwarf anything Earth has ever experienced. In a single moment, a flare from Proxima can unleash hundreds of times the energy of one of our sun's strongest solar storms. For Proxima b, there is no escape. Locked in tight orbit, it circles its star every 11 days, so near that it is likely tidally locked, one face forever scorched, the other frozen in endless shadow. The day side would endure constant bombardment from the star's radiation, its skies lit by brilliant, lethal flashes of ultraviolet and X-rays. The night side, shielded from light, would sink into silence, a wasteland of ice stretching under a black sky. Between the two extremes might lie a narrow twilight band, a fragile refuge where temperatures could soften just enough for liquid water to exist. But even that twilight may not last. Without a strong magnetic field to deflect charged particles, Proxima B's atmosphere would erode over time, molecule by molecule, carried away into space by the star's relentless wind. What begins as a whisper of air could end as a barren vacuum. On Earth, our magnetic field is a shield, the invisible armor that protects oceans and life from the solar wind. Without it, we might resemble Mars, stripped and silent. For Proxima b, such protection may never have existed. And yet, there are possibilities. Perhaps the planet's gravity holds onto its air more tightly than we think. Perhaps the flares trigger chemical reactions that rebuild its atmosphere, balancing destruction with renewal. Even on Earth, the seeds of life emerged amid chaos. Lightning, radiation, and violence gave rise to complexity. Could the same be true beneath a red sky? Astronomers have observed Proxima's flares in ultraviolet and X-ray light, each burst a pulse of danger across the void. These storms remind us that habitability is not just a question of distance or temperature, it is a matter of resilience. A world must endure its parent star, and in Proxima's system, survival is not guaranteed. But neither is extinction. To imagine standing on Proxima b is to imagine contradiction. The red sun above would blaze dimly, yet unpredictably. The horizon would glow with perpetual dusk. The air, if it existed, might shimmer faintly with charged particles from recent storms. The planet's nights would never know true calm, for danger would fall not from meteors or volcanoes, but from the very star that gives it life. In that balance between creation and destruction, Proxima b becomes a symbol of cosmic fragility. It shows us that not all warmth is kind, and not all light is gentle. Sometimes, the same star that offers hope also teaches humility. Because in the universe, survival isn't a gift, it's a negotiation. Even messages move too slowly. A signal from Earth would take over 4 years to reach Proxima b, and another 4 to return. Conversation becomes impossible. Every exchange is with the past. In the silence between stars, distance does more than separate. It distorts time itself. Imagine sending a message to another world, waiting not minutes or hours, but years for a reply. The act of communication becomes something closer to archaeology, a conversation with ghosts of a moment long gone. By the time your words arrive, the sender you once were has changed, and by the time the answer comes back, the world you left behind might no longer exist. Radio waves, traveling at the speed of light, are our fastest messengers. They have carried humanity's voice into space for over a century. Songs, broadcasts, commands to distant probes. Yet even light, with all its swiftness, falters before the tyranny of distance. Between Earth and Pluto, a signal takes about 5.5 hours. Between Earth and Proxima b, it would take 4.24 years. For every question asked, nearly a decade passes before the conversation completes a single loop. If a probe were ever to orbit Proxima b, every command we sent to it would be a letter to the future. A correction, a new instruction, a simple hello would arrive 4 years too late. We could not steer it in real time, could not warn it of danger or adjust its path. It would have to think for itself, to become, in essence, an autonomous explorer, guided not by human hands, but by human trust. The communication abyss transforms our relationship with discovery. On Earth, we are used to immediacy, to data flowing instantly, to feedback arriving within seconds. But in interstellar space, patience is not a virtue, it is a requirement. Scientists would wait years for images, decades for updates. Each transmission from such a distance would be an event, an echo of our curiosity finally coming home. In this silence, time becomes almost poetic. Imagine the first message we send to Proxima b, perhaps a simple greeting, a recording of ocean waves, or the hum of human laughter. When it arrives, nearly half a decade later, who will be there to hear it? And when their reply begins its long return journey, who among us will remain to listen? Each signal becomes a monument to continuity, proof that somewhere, someone once cared enough to reach out. Even our telescopes, our eyes on the cosmos, are bound by this delay. Every observation we make of distant stars is history, light that began its journey long before our species existed. The universe is always older than the moment we see. To look outward is to look backward. To speak across it is to speak into time itself. Perhaps that's the lesson of the communication abyss. That connection, in the grandest sense, isn't about speed or proximity. It's about persistence. Even knowing that replies may never come, we still send our signals into the dark. Because somewhere beyond those 4 light years of silence, there might be another world listening. And in that act of calling out into the unknown, we prove that distance can slow us, but it can never quiet us. We call Proxima close because we crave meaning in numbers, but our scale of distance collapses in space. The human brain cannot truly grasp a light year. It's like trying to imagine infinity measured in footsteps. 4 light years doesn't sound far, not when you say it aloud. It feels small, almost intimate, like something you could traverse with enough persistence. But in truth, it is an expanse so vast that even metaphors fail. Between Earth and Proxima Centauri lies an emptiness so deep, so cold, and so unbroken that words like close and far lose all relevance. In that gulf, there are no roads, no signposts, no horizon, only silence measured in the language of light. We invent numbers to make sense of it. 10 trillion kilometers in a light year, 40 trillion to reach Proxima. We evolved to think in walking distances, in the scale of mountains and rivers, not in the unimaginable gulf between suns. To us, Proxima is a neighbor. To the universe, it's across an ocean that has no shore. Even light, which defines speed itself, must labor across that space for over 4 years just to say hello. Our fastest spacecraft would take tens of thousands of human lifetimes to make the same crossing. It's not just that the stars are far away, it's that our entire sense of distance, of movement, of scale, collapses when measured against the cosmos. Astronomers often describe the Milky Way in familiar terms: 100,000 light-years wide, billions of stars, 10,000 planets for every grain of sand on Earth. But these comparisons don't make the vastness smaller. They only remind us how little we can truly perceive. The mind strains to visualize what it means for light to travel uninterrupted for years, for decades, for millennia. Even the speed of thought falters. That's why we say Proxima is close. It's not a measure of proximity, it's an act of hope. It's our way of bridging an incomprehensible gulf with language that still feels human. We compress infinity into a single word because otherwise the truth is unbearable. Close gives comfort. It makes the cosmos feel reachable, even if only in imagination. And yet, in that illusion lies something beautiful. Because every time we call Proxima close, what we're really saying is possible. We're admitting that no distance is too great to dream across. The human mind may not grasp the scale, but the human spirit refuses to accept its limits. So we keep looking up, calling faraway stars our neighbors, mapping the infinite with words too small to hold it. Because maybe close isn't about distance at all. Maybe it's about connection, the invisible thread between here and there, between knowing and wondering. Proxima isn't near, not by any measure the universe respects. But when we speak its name, when we imagine its red light flickering across unseen oceans, it feels close enough to touch. And perhaps that's all that matters. That in a cosmos built on unimaginable scales, imagination itself becomes our bridge across the void. Science fiction offers solutions: warp drives, wormholes, cryosleep. But even imagination bows to physics. The universe allows travel, but not shortcuts. For as long as we've looked at the stars, we've tried to outthink the distance between them. When rockets and radio waves fail to satisfy, we turn to dreams, to stories of faster-than-light drives, shimmering gateways, and hibernating travelers who awaken centuries later beneath alien suns. These inventions aren't just fantasies. They're expressions of longing, of humanity's refusal to be confined by what's possible today. We build ships out of thought before we ever forge them from steel. Warp drives, the crown jewel of interstellar imagination, promise to bend space itself, compressing distance so that travel becomes not a matter of speed, but of geometry. The idea isn't purely fiction. Einstein's equations describe how mass and energy can warp spacetime, and physicist Miguel Alcubierre once proposed a theoretical warp bubble that could carry a ship faster than light by contracting space in front of it and expanding it behind. It would be motion without movement, travel without breaking the cosmic speed limit. But the mathematics come with impossible demands. The energy required would exceed the mass of entire planets. Worse, it would require negative energy, a kind of exotic matter that has never been proven to exist. Even if it could be created, controlling it would be like holding lightning in your bare hands. Warp drives live where physics and poetry meet. Beautiful, impossible, and endlessly inspiring. Then there are wormholes, tunnels through space-time, shortcuts connecting distant corners of the universe. They exist in theory, born from the same equations that describe black holes, but in practice, they are fragile. A traversable wormhole would collapse the instant anything with mass entered it, unless stabilized by exotic matter even stranger than that demanded by warp drives. The universe, it seems, is not fond of easy paths. Cryosleep offers a different escape, not from space, but from time. If we cannot reach the stars faster, perhaps we can simply wait through the centuries it takes to get there. Countless stories have imagined it, travelers frozen between heartbeats, drifting across the abyss, awakening to new worlds where their ancestors have become myths. Yet cryonics remains a dream. The human body is not made for pause. Ice shreds cells, chemistry falters, and consciousness, our most delicate creation, has no known way to survive centuries in silence. Even so, these ideas endure. They serve a purpose beyond engineering. They remind us that imagination is its own form of propulsion. Before the first rocket rose from the ground, science fiction had already sent us to the moon. Before we built telescopes capable of seeing exoplanets, writers had already walked on their imagined shores. The engines of imagination run on curiosity, not fuel, and they carry us further than any machine yet built. Perhaps the universe has rules we cannot break, but it also has wonders we have yet to understand. Every impossibility we dream of, every warp bubble, wormhole, and starlight sail, is a seed planted in tomorrow's physics. Because in the end, imagination is how we rehearse discovery. We dream first, then we build. And though the cosmos denies shortcuts, it never forbids dreaming. Some propose ships that sail for centuries, carrying entire civilizations born among the stars. But can culture, memory, and purpose survive when the destination lies beyond 1,000 lifetimes? A generation ship begins not with launch, but with surrender. It accepts the truth that no one aboard will see the end of the journey. Those who step inside do so knowing their children and their children's children will inherit a mission they did not choose, to live and die between suns, their entire existence confined to a moving fragment of humanity's past. It is both a vessel and a world, carrying not just bodies, but continuity itself. The concept seems noble at first, a self-sustaining arc, gliding across light years while civilization continues within its walls. Cities might form inside its rotating habitats, artificial gravity keeping people rooted as stars crawl slowly by. There would be farms beneath mirrored ceilings, schools teaching the languages of Earth long after Earth itself had changed. Inside such a ship, life would persist, but identity would evolve. The crew would become citizens of a new culture, one defined not by geography, but by motion. Yet time has a way of eroding purpose. What happens to a people who inherit a destination so distant that it becomes myth? After a few generations, the original goal, to reach another star, may seem less a mission and more a legend. The descendants of the first travelers might forget why their ancestors ever left. Some might come to see the ship itself as their home, the stars outside as unreachable dreams. Sociologists, have studied this idea in simulations. They speak of mission drift, where ideology and purpose dissolve under the slow tide of time. Maintaining discipline, education, and hope over centuries might prove harder than surviving the vacuum of space itself. A ship's ecosystem could be maintained by machines, but the ecosystem of belief, of unity, must be maintained by hearts and minds. What story would they tell their children to keep them moving forward through generations of darkness? And yet, there's something profoundly human about this idea. The notion that we could build a world to carry us across eternity speaks to our most enduring trait: perseverance. In a way, humanity already lives on a generation ship. Earth itself sails through space, carrying every life that has ever existed. We inherit it, we shape it, we pass it on. The voyage never ends. Only the passengers change. A true generation ship would make that metaphor real. It would need to balance biology and technology perfectly, recycling every molecule, preserving genetic diversity. Every sunrise would be artificial. Every horizon, painted metal. The stars would move so slowly that change itself might feel like a dream. Perhaps, by the time such a ship arrived at its destination, it would no longer carry humans as we know them. Evolution, biological or cultural, would have remade its inhabitants into something new. The original mission, to colonize another world, might no longer matter. What would matter is that they kept moving, kept surviving, kept wondering. The dream of generation ships is not just about reaching another star, it's about endurance. It's about asking whether meaning can survive the erosion of time. And maybe, in the end, the journey itself would become the purpose. To live, to learn. Between stars lies a storm of cosmic rays and interstellar dust. No hull can block it completely. A journey to Proxima isn't a voyage, it's exposure. The space between stars may seem empty, but it's anything but safe. It's filled with invisible fire, high-energy particles born from the deaths of ancient suns. These cosmic rays streak across the galaxy at nearly the speed of light, relics of supernovae and black holes, carrying enough power to slice through flesh, metal, and memory alike. For any traveler crossing the Gulf to Proxima Centauri, radiation isn't just a danger, it's a constant companion, an invisible ocean that cannot be escaped. On Earth, our planet's magnetic field and atmosphere protect us from most of this cosmic onslaught. The air we breathe and the magnetism that dances around our poles act as shields, deflecting deadly particles that would otherwise tear through DNA. Even astronauts in low Earth orbit remain under that invisible dome of safety. But once a spacecraft leaves it behind, once it ventures beyond the sun's protection, it enters a place where radiation is the weather and the forecast never changes. The solar wind, that stream of charged particles flowing from the sun, forms a protective bubble around the solar system called the heliosphere. Within it, life can endure. Beyond it lies the interstellar medium, a thin fog of gas, dust, and radiation that stretches between the stars. It's there that the true radiation sea begins, where the sun's influence fades and the universe itself becomes hostile. For a crewed mission, this radiation would be lethal over time. Cosmic rays pass straight through spacecraft walls, leaving trails of ionized atoms in their wake, disrupting electronics and damaging cells. Prolonged exposure could lead to cancer, nerve damage, or worse. Engineers can add layers of shielding, but every extra layer adds mass, and every kilogram makes propulsion harder. Some designs propose using water or hydrogen as a buffer, while others imagine surrounding the ship with an electromagnetic field to mimic Earth's protection. But no design is perfect. The longer the voyage, the greater the risk. Even uncrewed probes are not immune. Over decades, radiation slowly degrades circuits, corrupts memory, and wears down the very metal that holds them together. Voyager 1 and 2, now drifting in interstellar space, continue to survive not because radiation is kind, but because luck and engineering have bought them a little more time. They are testaments to endurance, small sparks of human will moving through an endless storm. To imagine a ship sailing through this radiation sea is to imagine vulnerability stretched across eternity. Each second would bring a rain of particles older than Earth itself. Each meter traveled would pass through the ashes of exploded stars. The darkness between suns is not emptiness. It is the residue of creation, the breath of cosmic history still burning in motion. And yet, even here, there's a strange beauty. Those same cosmic rays that threaten life are also its architects. They helped forge the heavy elements that make up planets, oceans, and blood. Without them, there would be no iron in our veins, no carbon in our cells, no light for our eyes to see. The universe builds and destroys with the same hand, and we are born of both its fire and its silence. So, yes, between stars lies danger, but within that danger lies our origin, and perhaps our destiny. Yet still, we reach for the stars, not because the journey spares us, but because the storm itself is proof that we are part of the cosmos we long to explore. Perhaps the answer isn't faster travel, but longer vision. To build not for decades, but for millennia. To send ships not for us, but for whoever comes after. In a universe where light takes years to move between neighbors, speed is not the only path forward. Sometimes, the true key to exploration is endurance, an ability to think beyond the span of one life, one generation, even one civilization. Humanity has always measured progress by what we can achieve before the end of our lifetime. But space asks something different of us. It asks for patience. Not just in waiting, but in believing that a goal worth reaching may never be reached by the hands that begin the work. Every great act of discovery begins with faith in the unseen. The builders of cathedrals in medieval Europe carved stones, knowing they would never see the final tower completed. The planters of ancient trees did so for descendants they would never meet. In much the same way, interstellar travel might require that same humility, a willingness to build for a future we can only imagine. A ship designed to reach another star could take centuries, perhaps millennia, to arrive. Its journey would outlast empires, languages, and entire epochs of history. Those who launched it would become myths to its eventual passengers. And yet, even that possibility holds power, because in the long timeline of the cosmos, patience is not weakness, it is strength. Stars live for billions of years. Galaxies turn like slow whirlpools of eternity. Against that backdrop, the human idea of too long loses meaning. Perhaps the next great era of exploration won't be defined by speed, but by persistence. Instead of racing to reach Proxima B, we may send probes that drift gently, powered by sunlight or ion streams, each carrying seeds of knowledge, waiting quietly as the centuries pass. These vessels would not be built to rush, but to endure. Like Voyager, our first messenger to the interstellar medium, they would carry the story of who we were, hoping that someone, someday, might listen. And as we learn to think on longer scales, even our definition of success will change. We may never set foot on another star, but the act of sending something, of trying, becomes its own form of victory. Each probe that leaves the solar system is not a failure to arrive, but a testament to perseverance. The universe rewards patience in its own language. It speaks through slow processes, the formation of worlds, the birth of stars, the cooling of light. When we align with that rhythm, when we build for millennia instead of moments, we begin to participate in the cosmos rather than struggle against it. Maybe our role isn't to conquer the stars in a single lifetime, but to become part of the long story of reaching them, to light beacons that others will follow, to pass on the flame of curiosity, generation after generation. Because exploration, at its core, isn't about arrival, it's about continuity. The power of patience is the power of legacy. It's the courage to start what you may never finish, and the trust that someone, someday, will continue the journey. And in that long waiting, in that quiet persistence, humanity might finally find its place among the stars, not as conquerors, but as caretakers of an infinite story still unfolding. Imagine sailing not across water, but across light itself. Each star a distant island, each journey an act of faith. The universe is not made for arrivals, but for exploration. If you could step outside the Milky Way and look back, you would see it as a vast spiral of light, hundreds of billions of stars drifting in a sea of darkness. From afar, it might seem solid, like a glowing whirlpool frozen in motion, but up close, that light unravels into distance. The spaces between stars are immense, each one separated by emptiness so deep that even light, racing at cosmic speed, takes years to bridge it. To cross from one to another would be like trying to swim across an ocean where every drop of water is a lifetime. And yet, we call it an ocean for a reason. There is rhythm in the cosmos, a current of motion and meaning. Stars are born in nebular clouds, billowing seas of dust and hydrogen that glow with the first stirrings of fusion. They burn for billions of years, then die in brilliant outbursts that scatter their remains across space, seeding the next generation of suns. In that endless cycle of creation and collapse, the galaxy breathes, and we, tiny as we are part of its inhale. When we gaze at the night sky, we are sailors at the edge of an uncharted sea. Every point of light is a potential world, every glimmer a promise that there is more to know. The constellations our ancestors drew were maps of imagination, ways to give form to mystery, to turn chaos into story. They didn't just see stars, they saw destinations. Even before we could leave the ground, we were plotting routes across eternity. To travel among the stars would be to embrace that same spirit. Each voyage would be an act of surrender to scale, an acknowledgement that the universe does not exist to be conquered, only explored. There would be no quick crossings, no convenient harbours, only patient movement through silence. One faint light at a time. Perhaps one day our ships will sail on sunlight, great reflective sails catching the push of photons, gliding slowly through the interstellar dark. Each beam of light from the sun, born in its core millions of years earlier, will become wind for our journey. And with it, humanity will drift outward, not as conquerors of the cosmos, but as its students. In that vastness, the stars become more than destinations, they become companions. We are not outside the universe, moving through it like travelers through a foreign land. We are of it, currents of consciousness within its tide. The hydrogen that fuels the stars is the same element that fuels our breath. We are, quite literally, made of the ocean we seek to cross. The universe may not be made for arrivals, but it is made for wonder. Every star that twinkles in the night sky is a reminder that the voyage never ends. There will always be more to see, more to learn, more to imagine. So we keep sailing, through data, through dreams, through the boundless dark. Because even if the stars are unreachable, they are not beyond meaning. They are the lights that guide us home. No matter how far we drift, between our solar system and Proxima lies pure emptiness. No planets, no moons, no dust dense enough to reflect light. A void so vast that even gravity feels tired. It is the truest kind of silence. A place beyond noise, beyond warmth, beyond presence. Here, the sun is little more than a bright star, and Proxima Centauri is just another point in an infinite field of glittering distance. Between them stretches a region of space nearly incomprehensible in its emptiness. A desert of darkness, extending for over 40 trillion kilometers, where nothing large enough to hold meaning drifts. If you could stand in that void, if such a thing were possible, you would see stars in every direction, frozen pinpricks in an eternal night. There would be no horizon, no motion, no echo. The Milky Way would spill across the blackness like a river of light, but even that light would offer no comfort. For in the silent middle, you are between everything and nothing at once. You are beyond the reach of both suns. This is the interstellar gulf, the true wilderness of the cosmos. It's not filled with color or sound, but with loneliness measured in years of light. Even the density of matter here defies imagination. A few stray atoms per cubic centimeter, scattered like dust in a cathedral too vast to see. In every cubic kilometer of this space, there are fewer particles than in a single breath on Earth. Space, in its purest form, is almost nothing at all. And yet, even this emptiness is not entirely empty. Invisible forces still rule the dark. Threads of gravity stretch through it, linking stars into constellations, constellations into clusters, clusters into galaxies. Occasionally, a lonely hydrogen atom collides with another, or a cosmic ray tears through at near light speed, a brief flicker of energy that will never be noticed. These are the only movements, the only whispers in this otherwise perfect stillness. To cross such a void is to face the limits of endurance, both mechanical and emotional. For a spacecraft, there are no refueling points, no magnetic fields to harness, no sunlight bright enough to power its systems. Every watt must be conserved, every signal stretched thin across decades. And for the mind, human or machine, this silence could become unbearable. There are no landmarks to measure progress, no visible change for years, no sense of arrival. Time itself would seem to dissolve. Yet, this nothingness has its own strange beauty. It is the space between heartbeats, the pause that gives rhythm to the song of the cosmos. Without the silent middle, the stars could not exist. It is the void that gives shape to light, the distance that allows gravity to weave galaxies from emptiness. Even in its absence, it defines everything. Perhaps that is why we are drawn to it, not because it promises life, but because it reminds us of contrast. The dark between the stars is what makes their light matter. The silence between words is what gives them meaning. The empty gulf between suns may seem lifeless, but it is the stage on which existence itself performs. The silent middle is more than distance, it is perspective. It reminds us that even in the vastest quiet, the universe still listens. Einstein taught us that as we approach light speed, time slows. For the traveler, centuries could pass in moments, but for those left behind, entire civilizations would vanish into history. It's one of the strangest, most beautiful truths of the universe. Time does not flow the same for everyone. To us on Earth, it feels constant, steady, unbroken, predictable. But in the realm of high speeds and immense gravity, time stretches and folds like fabric. It bends under the weight of motion itself. According to relativity, the faster you move through space, the slower you move through time. To reach the stars is not just to travel through distance. It is to step outside the rhythm of everything you've ever known. Imagine a ship bound for Proxima Centauri, accelerating close to the speed of light. Inside, the crew might experience only a few years of passage. They'd eat, sleep, age, and dream as the stars drifted past in a slow, luminous stream. But when they returned, or sent word home, thousands of years would have passed on Earth. Empires would have risen and fallen, languages forgotten, continents reshaped. The world they remembered would be gone, its people long turned to memory. Time dilation isn't a fantasy, it's a measurable fact. Astronauts aboard the International Space Station age a tiny fraction of a second slower than those on the ground. The effect is minuscule at human speeds, but at near-light velocity, it becomes profound. To travel fast enough to cross interstellar space is to abandon the synchronization of human history. The faster you go, the lonelier you become, not just in space, but in time. For those on Earth, the traveler's journey would appear impossibly long. Centuries might pass before the light of their ship even reaches home, before their last transmission fades into static. To the crew, it might feel like a few short years. Both experiences would be true. Time itself would have bent differently for each. That paradox, one moment stretched into infinity, is the cruel poetry of relativity. And yet, hidden within that same physics lies a strange mercy. Though light speed remains an unreachable limit, it also offers protection. The laws that slow time for the traveler keep them safe from centuries of decay. If they could somehow endure the acceleration, the ship's passengers might outlast entire eras of human history, living through what feels like a brief voyage, while the universe around them evolves beyond recognition. But the price of that journey is detachment. To travel fast enough to cheat time is to leave behind not just your home, but your place in history. You could arrive at Proxima b only to find that the Earth you departed is ancient myth, that humanity itself has changed into something unrecognizable or vanished entirely. For those who travel, time would be merciful. For those who wait, it would be eternal. Einstein's equations showed us that time and space are inseparable, a single fabric woven by motion and mass. The faster we move through one, the less we move through the other. In this way, time becomes the true distance between stars. It is not just light years that divide us, but centuries. To reach another world might mean stepping into the future so far ahead that it feels like forever. The traveler would survive, but their home would not. And so, the physics of forever is not just a problem of propulsion, it's a problem of belonging. We can build ships strong enough to cross space. But can we build hearts strong enough to cross time? In space, mass is everything, and fuel is mass. To accelerate faster, we need more fuel. But the more fuel we carry, the heavier we become. It's a loop with no escape. Every rocket ever built has faced this paradox. The laws of physics are unyielding. To move forward, you must throw something backward. Motion in space is not about thrust. It's about exchange. Momentum must be conserved, and energy must be paid for. That payment is fuel, and in the vacuum of space, fuel is weight. Each extra drop needed to reach further adds mass that demands more energy to move. It's an endless spiral, a paradox that haunts every dream of deep space travel. This is the tyranny of the rocket equation, written by Konstantin Tsiolkovsky over a century ago. It defines how much fuel a ship must carry to achieve a certain speed. The result is cruelly exponential. The faster you want to go, the more fuel you need, and the more fuel you need, the heavier your ship becomes. To reach even a fraction of light speed, a vessel would require more fuel than the mass of entire planets. Consider this. The Saturn V rocket, which carried humans to the moon, stood taller than a skyscraper. Yet of its 3,000 tons, almost all of it, over 85%, was fuel. The astronauts, the capsule, the science, and the hope of humanity all rode atop a few small compartments, carried forward by fire that burned away almost instantly. And that was just to reach the moon, a mere 384,000 kilometers away. Proxima Centauri is more than 40 trillion kilometers distant. To cross that distance with traditional propulsion would be like trying to swim across an ocean by burning the water you're floating in. You can go farther only by carrying more of what slows you down. Even the most efficient engines, ion thrusters, nuclear propulsion, or theoretical fusion drives cannot escape the basic truth. Motion has a cost, and that cost grows heavier the faster you try to pay it. The universe demands patience, not brute force. That's why future concepts look beyond carrying fuel entirely. Solar sails might harness the pressure of starlight, letting photons push a ship forward slowly, endlessly, without ever running out of energy. Others imagine magnetic sails, catching the charged particles of the solar wind. Or perhaps one day, antimatter or dark energy could be harnessed. Energy sources so potent that mass itself might become an afterthought. But until then, we remain bound by weight. Every kilogram of fuel adds a burden. Every dream of speed adds another chain. Even the vacuum, empty as it seems, resists our ambition. Not through friction, but through the cold logic of mass and momentum. The irony is poetic. In the vast nothingness of space, nothing is what weighs us down. It is the absence of resistance, of gravity, of air itself that makes movement so unforgiving. The void gives no help, no lift, no wind to catch. It demands that we bring everything with us, our energy, our sustenance, our courage, and in doing so, reminds us how fragile motion truly is. In the end, every starship we build will carry this paradox within its frame. The faster we chase the light, the heavier our hope becomes. And perhaps that is the quiet truth of exploration. That progress isn't about escaping limits, but learning how to live with their gravity, even when surrounded by nothing at all. Every voyage is an equation: force, velocity, mass, energy, all balanced against the one constant: distance. And in that balance, even hope has a cost. Beneath the poetry of exploration lies arithmetic, unforgiving, indifferent, and absolute. The cosmos doesn't care about longing or courage or destiny. It only listens to numbers: how much energy you can produce, how much mass you can move, and how far that energy can carry it. Every dream of reaching another world must pass through this quiet gate of calculation, and more often than not, the math says no. Motion in space is simple in theory, brutal in practice. Every acceleration demands energy, and every bit of energy has to come from somewhere. The faster you wish to travel, the more energy you must feed into the system, energy that grows quadratically with speed. To double your velocity, you need 4 times the energy. To reach 1/10 the speed of light, you need fuel measured not in tons, but in entire planetary masses. That's because energy and mass are not separate. They are the same thing, intertwined by Einstein's most famous equation, E equals mc squared. It's an elegant truth, but also a merciless one. The energy required to propel even a small ship to relativistic speeds approaches the total energy the Earth receives from the Sun in a day. A human civilization could spend centuries building such power, only to use it in a single burst that flings one fragile vessel into the dark. And still, the math doesn't stop there. Acceleration is only half the equation. Whatever speed you gain must one day be undone. To slow down near another star requires the same energy you spent getting there. Every journey must be mirrored in reverse. A perfect symmetry of expenditure. The equation always closes, and the bill always comes due. This is the cold truth of motion. There are no discounts for ambition. The cosmos demands exact payment for every meter gained. Even light, the fastest traveler in existence, cannot cheat the balance. It moves at the ultimate speed only because it has no mass at all. Everything heavier, everything made of matter, must compromise. Engineers and physicists dream of breaking the equation. They speak of fusion drives, antimatter propulsion, photon sails, technologies that might someday push the limits further. But the numbers remain vast. Each concept trades one difficulty for another. Immense energy for impossible materials, enormous thrust for infinite patience. And yet, humanity persists. We build anyway. We calculate, adjust, refine, because somewhere in those equations, hidden between the decimals, there's room for courage. Hope may not appear in the formulas, but it exists in the hands that write them, in the quiet defiance of minds that keep trying to make the math yield to meaning. Perhaps that's what separates us from the vacuum. We count, but we also dream. We see the numbers for what they are, limits, and still imagine what lies beyond them. The cold math of motion may define what's possible, but it cannot define what's worth trying. In the end, every journey through space is a conversation between logic and longing. The equations tell us how far we can go. The human spirit answers, softly but firmly, farther. Light is the fastest thing in existence, yet even it cannot keep up with our curiosity. The stars we see tonight may have already died, their light still racing toward us through memory. Every glance at the night sky is an act of time travel. Each star above is not a point in space. It's a point in history. The glow we see left its source long ago, traveling tirelessly across the void. Some of that light began its journey before humanity existed, before the earth had mountains or oceans or breath. When we look upward, we are not seeing the universe as it is, we are seeing it as it was. The cosmos we witness tonight is already gone, replaced by a new one that we will not see for ages yet to come. Light is astonishingly fast, 300,000 kilometers per second, swift enough to circle Earth 7 times in a single heartbeat. Yet even that speed falters before the scale of the universe. The nearest star, Proxima Centauri, is 4.24 light-years away. That means its light, shining into our telescopes right now, set out when we were still 4 years younger. From the Andromeda Galaxy, the nearest large neighbor to the Milky Way, light takes over 2 million years to arrive. Every photon that reaches us from its spiral arms began its voyage when early humans were first learning to shape tools from stone. Even within our own galaxy, light struggles against distance. The Milky Way is 100,000 light-years wide. That means light from one edge takes longer to reach the other than the entirety of human civilization has existed. Somewhere out there, stars may have flared, planets may have formed, and civilizations may have risen and fallen, and their stories are still on the way, carried by beams of light that will not arrive until long after we're gone. It's a humbling realization. We tend to think of light as instant, as immediate truth. But in the cosmos, even truth has a delay. The stars we see may already be ashes, their worlds cold and silent, and yet their light continues to travel, undiminished, unwavering, a message from the past, declaring that they were. The night sky is not a map of space, but a museum of time. Astronomers rely on that delay to understand the universe's history. Each photon that reaches a telescope is a record, a frozen instant of the cosmos as it once was. By collecting enough of them, we can read the story of creation itself, the birth of galaxies, the first stars, the fading echo of the Big Bang. The further we look, the older the light becomes, until we approach the edge of time itself. And yet, even as light brings us knowledge, it reminds us of our limits. We cannot see the present universe, only its past. We are always a few heartbeats, a few years, a few million millennia behind the truth. Our curiosity races faster than any photon, reaching for a now that physics will never let us touch. Perhaps that's why the stars fascinate us so deeply. They are proof that the past never truly disappears, that what once shone can still be seen, even long after its source has gone dark. In a way, the light we see is not just starlight, it is memory made visible, time itself glowing softly against the dark. And maybe that's enough, because even if we can never outrun light, we can still follow it, tracing its path across eternity, learning not just where the universe has been, but who we are for daring to look at all. Voyager, Pioneer, New Horizons, all still drifting, all still whispering home. They are humanity's longest echoes, tiny emissaries of a species that dreams of the impossible. In the cold expanse beyond the planets, our machines have become our messengers. They sail where no human hand will ever touch, carrying our curiosity like a flame that refuses to go out. Their journeys began decades ago, with bursts of fire from launch pads on Earth, simple arcs of engineering and faith. And now, long after their missions have ended, they continue onward, unbound and unstoppable, crossing into the deep silence between stars. The Pioneer probes were the first to escape the sun's grasp. Launched in the early 1970s, they became the trailblazers of the outer solar system, sending back the first close-up images of Jupiter and Saturn. Etched onto their metal sides are golden plaques depicting a man, a woman, and a map of our place in the cosmos. A message meant for whoever, or whatever, might find them long after we're gone. It was humanity's first introduction to the stars. A simple, humble, we were here. Then came Voyager 1 and 2. Twin explorers launched in 1977. They toured the giant planets, Jupiter, Saturn, Uranus, Neptune, capturing sights no human eye had ever seen. Volcanic moons, icy rings, and storms the size of worlds. After their encounters, they continued outward, slipping past the edge of the heliosphere into true interstellar space. Today, Voyager 1 is more than 24 billion kilometers from Earth, the farthest any human creation has ever traveled. Its signal, faint as a whisper, takes over 22 hours to reach us, crossing the void like the echo of a memory that refuses to fade. On board, Voyager is the golden record, a time capsule of Earth's story. Encoded in its grooves are greetings in 55 languages, the sound of laughter, the crash of waves, and the music of Bach and Chuck Berry. It carries images of forests, animals, and human faces. If it is ever found, it will speak for all of us, not as conquerors of space, but as participants in it, as a species that looked up and wondered what might be beyond the dark. And then there is New Horizons. Launched in 2006, it reached Pluto in 2015, becoming the first to visit that distant, icy world. The images it sent home revealed mountains of frozen nitrogen, plains of methane ice, and the faint halo of an atmosphere glowing in the sunlight of a dying day. After its triumph, New Horizons pressed on into the Kuiper Belt, where it encountered another relic, Arakoth, a contact binary untouched since the birth of the solar system. It now drifts into the deep, its sensors still awake, still watching, still sending whispers home. Together, these machines form a constellation of our making, each one a story told in motion. They remind us that exploration doesn't end when the mission does. Even as their power fades and their voices dim, they continue their silent pilgrimage, carrying fragments of Earth into eternity. Someday, their transmitters will fall silent. The last photon of their signal will fade into the cosmic background. But even then, they will remain, traveling endlessly, circling the galaxy like small, patient ghosts. Perhaps in 1 billion years, another intelligence will find them, trace the lines of the plaques or the grooves of the record, and know that somewhere, once, there were beings who dared to dream across the stars. They are not just machines, they are memory-made metal, faith-given form, and though they are drifting away from us, they are also carrying us forward, proof that even the smallest creations of humankind can endure the vastness of forever. Scientists dream of light sails, ships pushed by lasers instead of fuel, accelerating to 20% the speed of light. At that speed, Proxima could be reached in 20 years, but stopping there is another problem. Imagine a spacecraft no larger than a postcard, its surface a gleaming mirror of ultra-thin material. No engines, no fuel tanks, just a sail catching not the wind, but light. Photons, the smallest particles of energy, have no mass, yet they carry momentum. When countless photons strike the sail, they push, softly, persistently, endlessly. It's the gentlest of forces acting over the grandest of scales, a slow but unstoppable acceleration through the void. This is the vision of Breakthrough Starshot, one of the most ambitious scientific projects of the 21st century. The plan is elegant in its simplicity. Thousands of tiny probes, each just a few grams in weight, launched from Earth and propelled by a focused array of ground-based lasers. For minutes, an immense beam would pour tens of gigawatts of energy onto each sail, accelerating the probes to 1/5 of the speed of light, 60,000 kilometers per second. At that pace, they could cross the Gulf to Proxima Centauri in just 2 decades, turning what was once an eternity into a human lifetime. But the challenge isn't just getting there, it's what happens after. At that speed, there's no way to slow down. The same laser that launches the craft can't reach far enough to stop it, and the ship's tiny mass leaves no room for engines or fuel. The probe would rush past Proxima b in seconds, taking a handful of blurred images before vanishing forever into the dark. It would be a flyby, a glance, not a visit. Yet even that fleeting encounter would be history-making. A photograph of another Earth-sized planet around another star, captured by something humanity built, would transform everything we know about our place in the cosmos. It would be the first tangible connection between our world and another. The beauty of light sails lies not just in their speed, but in their philosophy. They abandon brute force for elegance, trading mass for light, fuel for patience. Instead of carrying energy, they borrow it from starlight, from lasers, from the cosmos itself. Once in motion, they could sail forever, carried by the faint pressure of radiation that fills every corner of the universe. Future generations may refine the idea further. Perhaps self-healing nanomaterials will make sails strong enough to endure decades of bombardment by dust and radiation. Perhaps spaceborne laser arrays orbiting the Sun will replace Earth-based launchers, pushing swarms of probes toward thousands of nearby stars. Each one would be a spark of human curiosity, a grain of thought cast into the deep. There's a kind of poetry in it too, using light, the very thing that connects the universe, to reach the stars that gave it birth. These ships would not roar or burn, they would glide silently across the interstellar sea. Their voyage would be powered not by fuel, but by faith, in physics, in progress, in possibility. We may never build great starliners crossing space in the style of fiction, but perhaps the first true interstellar travelers will be no larger than a hand, their sails shining faintly against the black, 1,000 fragments of Earth drifting outward, each carrying a single, eternal message. We are on our way. Reaching another star is only half the challenge. Once there, we must slow down. Without fuel to decelerate, our ship would fly past its destination forever, an eternal traveler with no port. In space, motion is forever. There is no friction, no resistance, no atmosphere to slow a vessel down. Once something accelerates, it will keep moving until acted upon by another force, and when that force is light years away, slowing becomes almost impossible. Every journey across the stars must obey this ancient law of motion. Whatever speed you gain, you must also one day undo. For a probe like the ones imagined in the Breakthrough Starshot project, reaching 20% of light speed is a triumph of physics and precision. But that same triumph becomes a curse the moment the destination nears. At 60,000 kilometers per second, even a grain of dust becomes deadly, and slowing down would require an energy input equal to that which launched it in the first place. But the tiny light sails carry no fuel, no engines, only momentum. They are the interstellar equivalent of a thrown stone, beautiful, fast, and unstoppable. This is the cosmic brake problem. Every push demands an equal pull. Our current propulsion systems are built for short bursts and nearby worlds. Rocket engines work wonderfully within the solar system, where gravity assists and fuel stores can be calculated in manageable amounts. But over interstellar distances, where each acceleration could take months or years, slowing down at the far end becomes a second journey, as costly as the first. Some scientists have proposed creative solutions. One idea involves using the destination star's own light as a brake, turning the same sail that caught Earth's lasers into a mirror that reflects stellar radiation in reverse, gradually reducing speed. Others imagine deploying magnetic sails, vast fields of plasma that interact with the interstellar medium, generating drag from the thin wind of charged particles between stars. These methods could, in theory, allow a ship to slow without burning fuel, trading time for gentleness. But time is the key variable in every proposal. Even with the most advanced designs, deceleration would require decades. The ship would need to begin braking years before it arrived, anticipating its destination long before it was in sight. It's a kind of cosmic choreography, delicate, invisible, and unforgiving. One miscalculation, one missed moment, and the ship would overshoot by light years, doomed to wander forever into the dark. The problem becomes even more daunting when humans enter the equation. A crewed vessel would need to protect fragile bodies and minds from prolonged deceleration forces, radiation, and isolation, all while ensuring the ship's life support systems remain functional for centuries. To stop safely at another star would require a technology that doesn't yet exist, one that can store and control energy on scales we can barely imagine. And yet, this limitation carries a strange beauty. The cosmic brake problem is a reminder that exploration is not just about movement, it's about balance. The same forces that carry us forward must one day return us to stillness. Every journey demands both the fire to go and the grace to stop. Perhaps one day, humanity will master that balance. We'll learn to use the light of alien suns to slow our approach, to drift gently into orbit around new worlds, to land softly on shores that have never known our kind. But until then, every probe we send, every dream we launch, is a traveler without a harbor, sailing endlessly through eternity, carrying the faint echo of our ambition through the infinite night. Space doesn't just challenge physics, it challenges biology. Radiation, microgravity, and isolation erode both body and mind. We are creatures of one planet, not yet built for the void. Every cell in the human body carries the memory of Earth, its gravity, its atmosphere, its rhythm of day and night. For billions of years, life evolved within the embrace of this world's protective cocoon. The pull of the ground shaped our bones, the weight of air shaped our lungs, the dance of sunlight and darkness tuned our minds. Out there, beyond that fragile shell, none of these constants remain. To leave Earth is to leave the conditions that built us. In microgravity, the body forgets how to stand. Muscles waste away, bones thin, fluids drift upward. Astronauts aboard the International Space Station must exercise for hours each day simply to slow their body's decay. Without gravity's constant pull, calcium drains from bones into the bloodstream, weakening them faster than any disease known on Earth. After months in orbit, returning to the ground feels like wearing a body made of stone, every step heavy, every breath unfamiliar. But the physical challenges are only the beginning. Cosmic radiation seeps through even the best shielding, bombarding cells with invisible shrapnel. DNA unravels, mutations bloom, and the risk of cancer grows with every passing day. On a long voyage to another star, there would be no refuge, no magnetic field to deflect the storm. The same energy that births worlds and lights the heavens becomes a slow, relentless poison. Then there is the mind. The silence of deep space is not like any silence we know. It is total, eternal, a kind of sensory emptiness that erodes the soul. Astronauts describe the paradox of isolation, the awe of seeing everything they've ever known as a single blue dot, and the loneliness of knowing they may never touch it again. On a ship sailing for decades, that isolation would deepen into generations of detachment. The stars would become their ceiling, not their destination. Even time itself conspires against the human spirit. Circadian rhythms falter without the cycle of sunrise and sunset. Sleep becomes irregular, emotions unstable. Without Earth's familiar cues, the mind begins to drift, searching for a center that no longer exists. To survive, we would need to reinvent not just our technology, but our sense of self. And yet, there is resilience woven into our fragility. For every weakness space exposes, humanity has sought a countermeasure. Artificial gravity through rotation, radiation shielding made of hydrogen-rich materials, or perhaps even water, wrapping the crew in the same substance that nurtured life from the beginning. Psychological training, virtual reality, shared communication with Earth, all tools to keep the human spirit tethered through the long night. Still, there's no escaping the truth. We are not designed for the stars. Our bodies are stories written by this world, and every attempt to travel beyond it is an act of translation. To live among the stars, we would need to become something new, stronger, more adaptable, perhaps no longer entirely human. The fragility of flesh is not our failure, it's our origin. It's a reminder that even our greatest dreams are born from vulnerability. We reach for the stars not because we are invincible, but because we are fragile, and in that fragility lies our courage. The cosmos tests our limits, but it also reflects our strength. The quiet, stubborn will to keep going, even when everything we are was made for somewhere else. We are both tiny and vast. Our reach ends at the edge of the solar system, yet our imagination extends beyond galaxies. Perhaps that is what makes us infinite. From a cosmic perspective, humanity is almost nothing, a thin film of life, clinging to the surface of a small planet orbiting an ordinary star. The Milky Way alone holds hundreds of billions of stars like ours, each with its own planets, its own chances for life, its own stories we may never hear. And yet, in that ocean of existence, we dare to look outward and ask, what else is there? That question, quiet, persistent, and defiant, is what transforms us from dust into something more. We are creatures made of atoms forged in the hearts of ancient stars. Every cell, every heartbeat, every breath carries the residue of supernovae that burned long before Earth was born. In us, the universe remembers itself. Our eyes are not just organs of sight, they are instruments of time, receiving light that began its journey millions of years ago. Every time we look at the night sky, we are witnessing the cosmos reflecting on its own history. And yet, for all that wonder, we are fragile beyond measure. A thin atmosphere keeps us alive. A small shift in temperature or radiation could end us. We live in the narrowest of margins between chaos and balance. Between light and shadow, we build machines to extend our reach. But even those, Voyager, New Horizons, the rovers on Mars, are just sparks flickering at the edge of darkness. This duality defines us. We are small, yet we dream in infinite scales. We know how insignificant we are, yet we refuse to behave as if that's the end of the story. We name galaxies, map nebulae, send our voices into interstellar space, because to us, understanding is a form of survival. Every discovery, every equation, every story is a bridge between the finite and the infinite. Perhaps this is why our species thrives not in comfort, but in curiosity. We don't settle for the view from the ground. We climb, we launch, we imagine. The limits of our bodies do not bind the reach of our minds. Even if our ships never reach Proxima b, even if the stars remain beyond touch, we have already crossed the greatest distance, from ignorance to wonder. In that sense, we are both bound and unbound. Our feet are rooted in soil, but our thoughts drift among galaxies. Our hearts are fragile, but our ideas endure. We exist at the intersection of physics and poetry, matter that dreams. The human paradox is not a flaw, it's a miracle. We are the universe, momentarily aware of itself, questioning its own purpose, longing to return to the stars that made it. And maybe that longing, endless, impossible, beautiful, is what makes us eternal. Every time we look outward, we're really looking inward, seeing our own reflections scattered across the dark. We chase the stars not to escape Earth, but to understand why we were born here at all. It's easy to imagine that exploration is about distance, about moving farther, seeing more, touching what's beyond. But every telescope, every spacecraft, every act of discovery points not only away from us, but back toward us. The stars are not just destinations, they are mirrors. In their light, we find the outlines of our own questions, our own hopes, our own longing to belong somewhere in the vastness. When we study other worlds, icy moons, scorched planets, glowing nebulae, we are really studying versions of ourselves. We look for warmth and oceans because we know what it means to need them. We search for atmospheres that breathe because we understand the rhythm of air. Even our fascination with alien life is a reflection of a deeper wish, that we are not alone in feeling this ache for meaning. The cosmos, in a way, teaches empathy. To gaze at galaxies billions of light years away is to realize that we are part of something ancient and immense, and yet profoundly connected. The same atoms that fuel the stars move through our blood. The same physics that holds galaxies together holds our hearts in time. We are built from the same dust we study. Every photon that reaches our eyes began its journey before we existed, only to end here, in the brief flicker of our attention. And what a beautiful symmetry that is. The universe creates beings capable of wondering about it. We are both observer and observed, matter given consciousness, starlight turned inward. Every experiment, every photograph, Every theory is the universe attempting to understand itself through us. Even our desire to leave Earth, to stand on another world, is not an act of rejection, but of curiosity. We do not climb toward the stars to abandon our home. We climb to see it more clearly. From orbit, astronauts describe an experience known as the overview effect, a sudden, overwhelming awareness of unity. Borders vanish, divisions dissolve, and what remains is a single, fragile world glowing in the dark. Perhaps that's the purpose of our endless reaching, not to conquer, not to claim, but to reflect. Every probe we send is a question cast into the cosmos, hoping for an answer that helps us understand what it means to be alive. The stars are not separate from us. They are the beginning of us, the ancient furnaces that forged every element in our bodies. When we look up, we are not gazing into something foreign. We are looking at our own origin story, written in light. So when we chase the stars, we are not fleeing home, we are finding it. Because to know the universe is to know ourselves, small, fragile, luminous, and endlessly becoming. Maybe impossible doesn't mean never. Maybe it just means not yet. The road to Pluto was once a dream, and now it's a photograph. The road to Proxima will be the same. Throughout history, every great leap forward began as an impossibility. Flight was once a fantasy whispered by poets. The moon was a distant lamp, unreachable by any machine. The outer planets were flickers of light known only to telescopes and myth. Yet one by one, those impossibilities unraveled beneath the weight of human persistence. We build, we fail, we build again. And somehow, through that stubborn rhythm of curiosity, the unreachable becomes the routine. When Clyde Tombaugh discovered Pluto in 1930, it was nothing more than a dot of light, a mathematical guess confirmed by glass plates and patience. To imagine visiting it was absurd. The technology didn't exist. The cost was unimaginable. But 85 years later, New Horizons swept past that same dot and turned it into a world. Ice mountains, nitrogen glaciers, a heart-shaped plain. It had been there all along, waiting for us to learn how to see it. Impossible is the word we give to what we don't yet understand. It's a placeholder for potential, a sign that our tools, not our dreams, are too small. Every generation inherits the impossibilities of the last and transforms them into stepping stones. What was once science fiction becomes science fact, and what seems miraculous becomes mundane. The arc of discovery bends slowly, but always forward. Consider this. A century ago, the idea of seeing exoplanets, worlds orbiting other stars, was fantasy. Today, we've catalogued thousands. We can measure their atmospheres, detect their weather, and even estimate their colors. Proxima b itself, invisible to the naked eye, was discovered through the gentle wobble of its parent star, a signal so faint that it would have been lost to noise only decades ago. Technology gave us new eyes, and with them, new possibilities. So, when we say that travel to another star is impossible, what we really mean is that we haven't built the bridge yet. The math may seem cruel, the energy demands insurmountable. But history has a habit of humbling certainty. There will be breakthroughs we cannot yet imagine. New physics, new materials, new ways to think about distance and time. Humanity's progress is not a straight line, it's an unfolding horizon. And perhaps that's what makes us who we are. We exist to chase the edge, to stand at the border between the known and the unknown, and take one step further. Every spacecraft, every telescope, every act of wonder is a declaration against limitation. Impossible is not the end of a sentence, it's the beginning of a challenge. One day, someone will look back at our time, at our doubts, and smile at how small our impossibilities once seemed. Because that's how progress works. Yesterday's miracle becomes today's experiment, and tomorrow's discovery begins with a single act of belief. The road to Pluto began as a dream. The road to Proxima already has its first map, drawn not in kilometers, but in courage. So perhaps the point is not to reach these worlds, but to keep reaching anyway, to move, to imagine, to build. For in the endless dark between Pluto and Proxima, humanity finds its truest light. The universe was never meant to be conquered, it was meant to be contemplated. Every step we take outward, every signal we send, every dream we cast into the void is not just about arrival, it's about transformation. We change with every attempt. The effort itself, our persistence against infinity, is what defines us. Perhaps that is the quiet truth behind all exploration, that its purpose is not to shorten distances, but to deepen meaning. We may never stand on Proxima b, never watch its red dawn rise over an alien sea, but the fact that we want to, that we try, is what turns the darkness into something more than emptiness. It becomes a mirror for our courage. Between Pluto's frozen heart and Proxima's crimson glow stretches an ocean of impossibility. Yet we fill that ocean with ideas, light sails, fusion engines, messages engraved in gold. Across the centuries, we have turned curiosity into technology and technology into poetry. We've learned to see time as a dimension, to listen to stars like instruments, to dream not just of survival, but of understanding. Every generation carries the flame a little further, adding one more page to the story the universe is telling through us. The journey beyond distance is not one of propulsion, it's one of perspective. Every time we look outward, we expand inward. We remember that we are not separate from the cosmos, but expressions of it, atoms rearranged into awareness, stardust that learned to wonder where it came from. Even if no human ever sets foot on another world, we have already begun the journey. Our machines drift through interstellar space. Our light, radio, data, music spills outward at the speed of imagination. Somewhere, perhaps, another consciousness might one day receive it and wonder who we were, just as we wonder about them. And when that happens, it won't matter that we never arrived. What will matter is that we reached, that we built ships knowing they would never return, that we asked questions knowing the answers might never come, that we looked into the darkness and decided it was worth our gaze. In the end, space is not a frontier to cross, it's a conversation to continue. The distance between worlds is vast, but the distance between wonder and purpose is small, and every thought, every dream, every silent orbit we send into the unknown brings those two closer together. So maybe the journey was never meant to end. Maybe it's meant to remind us, again and again, that light only exists because there is darkness to define it, and that hope, like starlight, travels best across the void. Because in reaching for the unreachable, we do more than explore the stars. We discover what it means to be human. In the end, the distances remain. Pluto still circles in its frozen solitude. Proxima b still glows beneath a red sun, 4 years of light away. But maybe that's the point. The universe was never meant to be conquered. It was meant to be witnessed. Every star reminds us not of how far we are, but how far we've come. Each orbit, each dream, each question carries us a little closer to understanding who we are in the dark. So rest now, traveler of the infinite. The stars are still out there, waiting, and in their quiet light, you are already halfway there. Good night,